Okay guys, welcome. Let's talk a bit more about some more quadratic charts and also some more order charts. Okay, we are going to go over some sketches of this. Okay, we are looking to solve this exercise number 3. Um, but before that, let me give you some hints, all right, of what graphically a quadratic equation is, okay? Um, like I said in the previous video, a quadratic equation is always something that is like this: y equals ax squared plus bx plus c, okay? Now, what I didn't mention is that this a here, this coefficient a, the coefficient of the x squared, it gives you the not the shape of a parabola. It gives you the direction of the hole, of the concavity of the parabola. Okay, so if my a is positive, okay, if my a, going to zoom in, okay, a x squared plus bx plus c. If my a is a positive number, is bigger than 0, okay, that means my parabola will be something to the upside, okay? I repeat, if my a is positive, my parabola will be facing the upside. My cup will be on the upside, okay? Now, if my a is less than 0, my parabola will be something like this, okay? Will be facing the downside. Okay, so immediately I know by the value of my a what kind of parabola I would have. Okay, uh, what more? Now, a parabola that is facing up, it doesn't need to be like this, crossing the x and the y. You know, it might be, you can have your xy axis like this, and the parabola can be only like this. Okay, with only 1 0, only touching the x in one point. Okay, same goes if the parabola is facing the downside. It can be something like this. Okay, that also happens, and what also happens is something like this. Okay, where the parabola has no zeros, it doesn't touch the x axis. Okay, it doesn't have to touch. You know, facing the downside, you can have something like this. Okay, so there are all different types of parabolas, and all this positioning depends of the coefficients a, b, and c. But what defines if it's facing up or it's facing down, it's the value of a. Okay, if either is positive or if either is negative. Okay, alright, having said that, let's try to solve the first one. They sketch the following graphics. On the axis below, label the points where they intersect the axis. Okay, so what is this? Minus x squared. This is the same as having minus 1x squared. Okay, so this is my a. Okay, ax squared. And what is my a? My a is negative. So immediately I know that my parabola is facing down. Okay, my parabola must be one of those three, one of like that, or like that, or like that. Okay, it cannot be the three others. Okay, it can only be one of those three that are facing down. And also, the other thing that I can see, if I try to find the zeros, I will have minus x squared equals 0. That means x squared equals 0, because it's 0 divided by minus 1, which is 0. Okay, so x equals plus or minus the square root of 0, which is 0. And what is plus or minus 0? Plus or minus 0 is 0. Okay, we only have one 0, that is 0. Okay, we only have one root, that is 0. We only have one point where it touches the x-axis, which is 0. Okay, so given that, we call this a double zero. Okay, double zero. Why? Because normally we have two zeros, and in this case we only have one 0. Okay, so that's why we call it the double zero. Those two zeros are converted into 1, because plus or minus 0 is 0. Okay, it's only one value. Double zero. Okay, so my parabola touches the x-axis in this point here, and I know that this is the only 0, and I know that it's facing down. So my parabola can only be something like this, guys. Only something like this. Well, it's a very bad drawing, but you understand the... Okay, if you put this in an exam, it would be perfectly fine. Okay, try to do it symmetrical. Okay, I can do better than this. Let me try. Let me try a little better than this. Okay, so my point, the point where it touches my... Okay, so let me try like this to this side, and like this to this side. Okay. Okay, now it's perfect. Okay. Second one, x cubed. Whoa, this is another one. This is a harder one. Okay. I'm going to wipe out in here this thing. Okay, let me just wipe out this. Okay. The x cubed, normally x cubed is something. Guys, a linear equation only touches the x-axis in one point, normally. Okay. Quadratic equation, in the maximum it touches the x-axis is in 2 points. Okay, and the cubed equation touches the x-axis normally in 3 points. And this has to do with the power of the x. Okay, the quadratic has power 2. This means that potentially it can touches the x-axis in 2 different points. Okay, now the cube has a power 3, so potentially it can touch the x-axis in 3 different points. Okay, normally a cubed equation will be something like this. Okay, so you have 1 touch, 2 touches, 3 touches. In this case, crosses, 3 crosses of the x-axis. Okay, and it's possible to know what those crosses are with some analytic stuff. Okay, but in this case they are not asking for that. They are just asking you to draw the x cubed function. Okay, and okay, let's try to do it. If I know that my x cubed function normally is something like this, and this has 3 zeros, well, let's check out how many zeros this thing has. Y equals x cubed let's do x cubed equals 0, x equals the cubic root of 0, which is what? Which is 0. Okay, in this case we have a triple 0. A triple 0. They are saying to me that this is the only place where this function here touches the y, the x-axis. And now, is that possible? Well, it's possible if we draw it like this, something like this. It approaches and then it crosses and then it moves up. Okay, something like this. This is the function you are looking for. Okay, they are normally symmetrical also. Okay, so yeah. So yeah, it only touches in one point. You cannot have something like touching 3 points. Okay, so this must be the drawing of the x cubed function. It would not be like this if you had a negative x cubed, but that's for another video. Okay, because those functions are quite complex to study. Okay, so let's move on to another harder one. Sketches of different graphics are shown below. A, B, and C, yeah. Write the letter of the graphic that shows y equals 1 over x. 1 over x. Okay. So, the best way of doing this is try to replace x by some values, okay? And see which is the graphic that makes any sense, okay? Because it must make sense. It must match somehow with the values that you find out. Okay, if I replace my x by, let's say, 1, for example, if I do my x equals 1, I will have my y. I will draw a table. Wait a minute. Okay, I will do a table like this. I'll do x and y. Okay. If my x is 1, my y is what? Well, my y is 1 over 1, right? My y will be 1 over 1, which is 1. Okay, so the point 1, 1 must be in the chart. Okay, so immediately I think I can discard this option C. You know, we might have the 1 1 here, we might have the 1 1 maybe here, it's possible. Okay, but in this one I'm not seeing the option C. I'm not seeing the 1 1 being possible. Okay, no. Okay, so only with this value I can already discard the C, the option C. Okay, now let's move for some bigger x's and smaller x's. Okay, if my x is 2, what happens? Well, my y is 1 over 2, which is 0.5. Okay, so if my x is 2, my y is 0.5. So if this is 1, this is 2. In the table, what I have is if my x increases, my y decreases. Look, my x is increasing and my y is decreasing. Okay? Option A makes perfect sense. Let's look at the option B. My x, this is 1, this is 2. 1 and 2. If I'm increasing my x in the second chart, my y is increasing. Okay, this makes no sense. This absolutely makes no sense. It cannot be option B. Okay, so immediately I can cross that out. Okay, and yeah, let's do some values to see if we continue to have. Let's say we have something between 0 and 1. Let's say 0.2, for example. If I replace my x with 0.2, what I have is that y will be 1 divided by 0.2. Okay, is the same as having 1 divided 0.2 is 1 divided, it's 1/5, right? Yeah, 1/5, yeah. 2/10, 1/5. So it's 1 divided by 2/10, okay? And yeah, so what we have is 1, okay, this is the same as writing. Sorry, I'm not trying to be complex. It's just I try for you to understand the best I can what I'm doing. Having 1 or having 1/1 is the same. 1/1 over 2/10. Why am I doing this? Because I need this to solve this fraction. Okay, I multiply the outer, I multiply the inner. I will have 10/2, which is 5. Okay, so when my x is 0.2, my y is 5. Okay, let's have that in mind. When my x is 0.2, let's call it 0.2, my y, this is, let's put, the drawing is not perfect, somewhere here 0.2, okay, and my y is 5. Let's call it 5 here. It makes sense, okay? This point is in the line, okay? It's a bigger number of y when the x is very, very small, okay? So for sure, I know this is the right option, okay, between A, B, and C. Well, I hope it is not too complex, guys. It takes a little experience to spot out those charts, but yeah, it's just keep doing it and keep seeing it, and after some time you have seen it all, okay, and you know exactly what is what. Okay guys, I will finish this video here. I hope you liked it, and subscribe for more, and thumbs up if you like it, please. Okay, cheers, see you in the next one. Bye bye.